In this short video, you will learn how to install and use PatternJ. PatternJ is a user-friendly toolset for ImageJ and Fiji. It will allow you to automatically analyze regular patterns. Such patterns are a very common type of organization in animals. You can find them in mussels, where sarcomere repeat themselves along myofibrils, or in the way feathers are organized on the skin of birds, just to name a couple of examples. PatternJ will allow you to extract features of these patterns automatically. It can offer some basic analysis, and it provides an average pattern image. This video is the companion of a manuscript by Mélina Baeblin, Vincent Laureau, Franck Schneurer, and Pierre Manjol. If you want to publish data analyzed with PatternJ, please cite us. This will help us to make more tools that will help more people. You will find a reference of this manuscript on the PatternJ website. If you are not already watching this video on the PatternJ website, you will find the link of the website in the description of the video. You can also download a written version of this video as a manual on the PatternJ website. To use PatternJ, you will first need to install it. The installation is very simple. You first need to go to the PatternJ website to download the toolset. Follow the link provided and download the zip file. Once the zip file is downloaded, extract it and move its content to the ImageJ or Fiji macro toolset folder. You will find this folder by first going to the macros folder, where you'll find the toolset folder. There, copy the PatternJ file and the icon folder. If an icon folder already exists, just merge its content with the PatternJ icons. Do not modify the name of the folder, otherwise PatternJ is not going to work. For Windows and Linux users, the installation is finished. For Mac users, we just need to add one more step. In PatternJ, you will be prompted to open files and folder, but unfortunately on Mac, we cannot guide you on which folder to use because of the very minimalistic interface. To solve this problem, open ImageJ or Fiji. In the menu bar, go to Edit, then Options, select Input Output, and there check Use JFile Chooser to open save. This will not affect the way you work with ImageJ, but it will help us to guide you when you use PatternJ. Now that the installation is finished, open Fiji or ImageJ if you have not already done it. Click on the double red arrowheads on the right of the ImageJ interface and select PatternJ. You will see that a few new buttons appeared on the right of the ImageJ interface. These are different functions from PatternJ. You are all set to start analyzing an image. You can download the example I will now use on the PatternJ website or use an image of your own. Once your image is open, you will first need to do a manual selection on the patterns you will find interesting. Here I'm using an image of sarcomeres from Drosophila mussel that was provided by my colleague Vincent Laureau. Depending on your application, this selection can be a straight line or a curve. When I trace the selection, you can see that I go a little bit beyond the patterns at the edge of the selection. I do that to make sure that the patterns at the extremities of the selection will be analyzed. You can adjust the line width by double-clicking on the line icon. It is generally better to increase the line width to cover most of the pattern width. Once you're happy with your selection, click on the first button on the left of the PatternJ functions. This will provide an intensity profile plots for each of the channels of your image. There you can check the different features that define the pattern. In our example, in the first channel, each pattern consists of two bands. In a second channel, we have a more complex pattern consisting of a block and a band in its middle. This is typical of haloidine staining in mussels. In a third channel, each pattern consists of a single band. What will be the most interesting for most users would be to extract the position of these features, just like the position of the center of the bands or the position of the edge of the blocks. To be able to do so, you will tell PatternJ what to look for. To this end, you will click the parameter button. When I clicked on the parameter button, a window opened to ask for a folder. This happens for most action in PatternJ because we want to make sure that the right parameters are used and that the results are saved in the right folder. Unfortunately, there is no other way to do it, but unless you have opened another file in another folder while you are using PatternJ, this usually will only require you to press Enter. Once the folder is selected, a pop-up window will appear. For each channel, you will set the features to be extracted. Depending on your applications, you can select individual bands, very close individual bands if your bands are only a few pixels apart, blocks, sarcomeric actin, single pattern if the pattern is so complex that there is no simple mathematical function to describe it, or other if you do not want a given channel to be analyzed. You can also specify where the pattern is centered. The vocabulary used here is the one of the muscle field, and it would probably be relevant mostly for this application. This parameter will only be important for the patterns that are at the very edge of the selection. In the general case, M-line can be seen as the edge of the pattern and Z-disk as the center of the pattern. If you are not sure, simply leave the parameters as they are, and in most cases, the analysis will work well. In our example, for the first channel, we said that we had 2 bands. Therefore, for channel 1, you will select individual bands in the drop-down menu. We have 2 of them per pattern, so we can just type 2 in a small box next to the drop-down menu. For channel 2, we have a sarcomeric actin, so here we're going to select sarcomeric actin. And finally, in the third channel, we have individual bands, and we have a single band, so we're just going to leave the one which is in a small box. Now that PatternJ knows what to look for, we are ready to extract the features of the patterns. For this, simply click on the Extract button. When doing so, a new window appears with the intensity profile, on top of which the position of the features are precisely found, witnessed by vertical bars. It is important at this step to check that the features are extracted as expected. If yes, you can continue and simply save the results by pressing on the Save and Extract button, which this is what I'm doing now. If unfortunately the algorithm did not fully extract the position of the features, try to modify the selection, making it smaller or larger. It is possible, if the noise is too large, that sparse positions are extracted. 2 solutions usually work. The easiest would be to use an optional features of PatternJ, which consists in applying a Gaussian blur to the image. The other option would be for you to use deconvolution, either through a dedicated software, just like Wiggins, or using ImageJ, which also offers deconvolution. Additionally, if the features of interest are dark, just like it would happen with electron microscopy images, you can invert the lookup table using the other optional button on the right of the PatternJ buttons. This function additionally corrects for background, which we found to be useful in many cases using electron microscopy images. Now that the results of the first selection have been saved, we can continue using another selection. Here you realize that you don't have to systematically set the parameters, as you only need to do it once. I make a new selection, check that PatternJ extracts well the position of the features, and then click again on Save and Extract to save the position of the features. In this tutorial, we'll only keep 2 selections, but you could have continued repeating these steps on more selections, on this image, or on more images. These images should all be in the same folder to make things simpler. Now we will reach the last step of PatternJ, the analysis. For this, simply press on the Analysis button. When you do that, you will first need to define one channel as a reference. It is used to estimate the length of repeats, and it is also used to align channels to obtain an average image of the pattern. Once the reference channel is selected, you will observe that 3 new windows appear. One is the histogram of the pattern length, and the 2 other ones contain the average pattern image and the average pattern intensity profile. The height of the average pattern image is related to the line width of your selection. If you draw multiple selections with different line widths, the smallest line width will be used to set the height of this average image. When the analysis is done, a new file appears in the analysis folder. These files contain all the position of the features as well as some fit parameters used to extract the position of edges. These files can easily be opened in Excel, R, or Python for further analysis. With the tutorial image, you can, for instance, estimate the distribution of distances between the 2 bands in channel 1 or of the distribution of width of the blocks in channel 2. I hope PatternJ will be useful for you, and all the best for your analysis.